All right, everybody. Gonna continue this progress here, right? Last time we did this subassembly. Now I'm gonna jump on to do our axle, right? So if you've been following along, assembly is where we put things together. Slides are where we make it custom, right? So I'm gonna go out here. I am going to grab an axle. You will see on the axle that it's longer than the follower, right? When you build this, that's going to be like common sense. When you are doing it in CAD, it's a little bit confusing. But the three parts that we need are a cam, and again, if you have multiple cams, you'll want multiple cams, an axle, and a crank. All right, so the next feature to this, you have to kind of understand what we want to do with each part, right? We want this axle to spin on this hole, all right? So because we're doing this in CAM, it may make sense for us to start thinking like, hey, we want some of our features. We already made the bottom fixed, right? We want some stuff to stay still, right? Obviously, we want our slider to be able to move up and down, but this box, we're not trying to move that whatsoever. And I think as you start playing with assemblies, it will make more sense, but I'm going to fix those. I'm going to say, hey, stay right where you are. So we're going to use multiple assembly features here. Fasten, revolute are the two main ones. Then we'll learn about one called tangent. All right. So if we jump over to Revolute first, what we are actually going to do is say, hey, I want this axle to spin around this hole, right? So a lot of you are going to get confused by this because of the connection points, right? It's not about where you click, it's about where the yellow circle is. When you are looking at the yellow circle, right, it's not always where your mouse is. If you hold the shift, you can kind of move to where that yellow circle is. It's going to make your connection point the closest to where your mouse is, right? So I actually went and did this one wrong intentionally because I want you to think about if I'm looking at my automata, if I'm building this for someone that's a left-handed person, it may make sense for my crank to be on that side. If it's a right-handed person, I want my crank to be on the right side. So this is where you're going to use what's called offset. All right, offset will allow you in any axis, I can move things wherever I want them to be. So you'll see that we're working in inches. I'm just going to move this 1 inch to the right. Because I'm looking at my back view, this may be a little bit confusing, but I'm going to have to say -1, or excuse me, +1, because I'm looking at this opposite, but it's also the z-axis. So again, what I like to do is try to plug in the number, and then if it goes the opposite way, just make it negative, right? It is just like plotting points. The other thing that I'm going to do is hit play so that I make sure that I like the revolve that's actually occurring, which I do. Okay. The next piece is going to be very much connected towards what we just did. We're going to make this cam. And again, you need to make sure that the yellow piece is where you want the connection. Where do we want to glue this? We want to glue this right here. And we want to glue this at the center here. The only difference is we want this cam to slide all the way over so that it's right underneath here. That's where offset comes in, right? So if you say -3.4, again, I've played with this a little bit more. Maybe you'd say 3.3, right? You can kind of you can make this what you want it to be. I'll go with 3.4 because I think that works. All right. If you have multiple holes, you're going to have to do either some math or measurement to understand where those will be. But at the end of the day, you can also play the slide game, right? Okay, so last thing, or second to last thing, is I am now going to fasten my crank to the axle, which is going to make this easier. I'm also going to flip this around. We'll use an offset of negative 0.25. That's positive, not negative, so that this is all now connected, right? So now as I turn this, that all works. Okay. So the last thing is as this turns, when you build this, you won't have to worry about this, but gravity is not exactly working in CAD, right? So we are going to use the tangent mate. And basically, a tangent mate means that I want for this piece to always be touching this piece exactly one place. Let me go here. Um, hold on a second. All right, hold on a second. Let me go back. Just got to get a better view at this, right? So the first edge we'll make here, and the second one we'll make here. Okay, and that is how you are going to end up actually allowing for this to work the way that you want, right? So engineers are going to do this in CAD first, so that we actually understand and make sure that our design is going to work before we manufacture it, because that costs money, right? So hopefully this makes a lot of sense. Looking forward to seeing what you create, and really want to see what you learn next.